Welcome. This lesson has a whole lot in it, so I'm going to dive in and get started right away. All right. In the past, we talked about how you could start with 3. That's just the side. You could square it and get 9. And we also talked about how you could start with 9 and you could take the square root, and then you would end up with just the side. Okay? Here's the notation. The square root of 9 is the same thing as the square root of 3 squared, which is the same thing as 3. Just a couple notes here. Inverses. Remember what an inverse is? It's when you do the opposite. So if you take x, you add 2, you subtract 2, you end up with x. Another example. You take x, you multiply by 3, then you divide it by 3, you end up with x. What do you think is going to be here? You take x, you square it, and then you take the square root, you end up with x. Okay. So, if the square root of 9 is the same thing as the square root of 3 squared, which equals 3, then what could we do with the square root of 75? Watch this. We could say that the square root of 75 is the same thing as the square root of 3 times the square root of 25. You see how we found a perfect square right there? Well, if that's the case, this is the same thing as the square root of 3 times the square root of 5 squared. This is an inverse. You take 5, you square it, then you take the square root of it. That's just the same thing as square root of 3 times 5. We just got rid of the radical sign and the square. This is a little messy because sometimes when you're writing fast, your radical sign might go a little bit too far and it's hard to see whether this number is under the radical. So by convention, we always write the number that's not in the radical outside of it at the beginning. This means 5 times radical 3. Okay? Watch me do one more. Here I am with square root of 24. I need to look for perfect squares that are hidden inside there, that are factors of it. Do you see any perfect squares that are factors of 24? Well, you might actually. You might realize that's the same thing as 4 times 6, right? Another way to do it is to do this. We can make a little factor tree first. Say that's the same thing as 8 times 3. This is the same thing as 4 times 2. This is the same thing as 2 times 2. We could write it out as primes. We could say that 24 is the same thing as 2 times 2 times 2 times 3. Now I look for any 2 of those primes which are identical. I'm going to take these 2. I can split it right here into factors. So the square root of 24 is the same thing as the square root of 2 squared, did you catch that? Times the square root of, what's 2 times 3? 6. So that would be the same thing as, let's see, you take 2, you square it, then you take the square root, that's just an inverse. 2 root 6. Okay, your turn. I'll try a couple of these. Let's take 60. Let's do a factor tree. 6 times 10, 2 times 3, 2 times 5. Those are all my primes. I'm going to write them in order. It's just the same thing as the square root of 2 times 2 times 3 times 5. Now I'm looking for matches. I'm looking for perfect squares. There's one. Let's take this one out. This is the same thing as the square root of 2 squared times the square root of 15, which is the same thing as 2 root 15. All right, just for time's sake, I got to move on. But you try these two by yourself. See if you can come up with this answer. The answer here should be 2 root 7. Let me think about this answer. We've got, I think this one is probably 6 root 3. Let me double check. If I do 36 times 3, yeah. See if you can figure out how to get from here to here and here to here. Okay, second objective, we're going to learn how to multiply radical expressions. We just did the square root of 75 equals the square root of 25 times the square root of 3. So can't we go backwards? If we start with the square root of 3 times the square root of 25, can't we just multiply what's under the radical equals the square root of 75? So, that being said, the square root of 2 times the square root of 5 is the same thing as the square root of 10. That's easy. Let's do this one. Square root of 3 times the square root of 6. That's the same thing as the square root of 18. But hold on, this radical can be simplified. That's the same thing as the square root of 2 times 3 times 3. Do you see a perfect square there? This pair is going to come out. That's the same thing as the square root of 2 times the square root of 3 squared. This is inverses, so we just say that this is the same thing as the square root of 2 times 3. But that's a little hard to see, so we move the 3 in front of the radical, and we call it 3 root 2. Okay? Your turn. Let's try a couple of these. Oh, you know what? I better show you how to do this one first. This means 2 times root 7 times root 14. I'm going to write this as primes right away. 2 times 7. Okay. So we're going to say this is the same thing as 2 times the square root of 2 times 7 times 7. I see my perfect square here. This is the same thing as 2 times root 2 times square root of 7 squared. This comes out of the radical. Okay, this is how it does it. This becomes 7 because those are inverses. So you've got 2 times root 2 times 7. Now, this is a little complicated. We can rearrange this. These two numbers just multiply together. That becomes 14 times root 2. Okay? Let's try this one now. Again, I'm going to start by writing this as primes. 30 is the same thing as 3 times 10. That's 2 times 5. So when I multiply, I end up with 3. Oh, sorry. Let me start with, I'm going to put them all in order. I've got 3 times 3 times 2 times 5. So we're going to do 2 times 3 times 3 times 5. Here's my pair. This comes out of the radical. Okay, how does it do that? That's the same thing as square root of 3 squared times the square root of 10, which equals 3 root 10. Okay? You try this one. Let's see if you can get this to equal, let me think. This should equal 36 times root, let's see, if you can get that to equal it. Okay, last objective, simplifying fractional exponents. This is a toughie. All right, take a look here. We've got the square root of 8. Is that a perfect square or an imperfect square? That's an imperfect square. That's going to be an irrational number. Look at this. We call this the cube root of 8. Okay. This number is going to be something like 2.7 going on to forever, something like that. Let me double checking. Sorry, it's 2.8. No, I got it wrong. It's 2.8 going on forever. It's got a whole bunch of different numbers times 2.8 going on forever, right? Over here, we call this the cube root. Just like the square root was the side of a square, the cube root is the side of a cube, right? So we have to think of a number that if you multiply itself by itself 3 times, oops, sorry, that's a 2. 2 times 2 times 2 is 3. So watch this. Over here, we wrote this as the square root of 2 times 2 times 2. And to simplify it, we took a pair out. We said that's the same thing as the square root of 2 squared times the square root of 2, which is just 2 root 2. And on this side, we're going to go like this, the cube root of 8. Once again, we just write 8 as its primes. But this time, we look for 3 numbers that match and take it out. We say this is the same thing as the cube root of 2 cubed. Those are inverses. That equals 2. Okay? So here's an example. This is the same thing as the cube root of 27. 27 is just 3 times 3 times 3. Here is a triple match. That comes out of the radical. So this becomes, these are inverses. This is the cube root of 3 cubed, which equals just 3. Okay, really clear here. If you're going to say cube root, that's the same thing as saying to the 1/3 power. So 8 to the 1/3 power means cube root of 8. We just did this on the other page, didn't we? So the cube root of 8 is 2 times 2 times 2. Take this one out. It becomes cube root of 2 cubed, which is just 2. Now it's out of the radical. Let's say we have a negative number. You should think of this as the opposite of. So this is the opposite of 1,000 to the 1/3 power, which is the opposite of the cube root of 1,000, okay, which is the opposite of, now I could go all the way to primes, but I see a number that's a composite number. It's not a prime number, but I multiply it 3 times and I get 1,000. So this is a little shortcut. 10 times 10 times 10. So I know that these 3 are going to be my triple that can come out. This should be a cube. So I've got the opposite of the cube root of 10 cubed is just